Cepheid variables. It was John Goodricke who in 1784 discovered that there was a star, Delta Cepheid, who was varying in its brightness. Delta Cepheid does that every 5.37 days. And the star is small, gets big and small, and that every 5.37 days. And whenever it is the smallest, it is the brightest. When it gets bigger, it gets dimmer. And when the star gets dimmer, still dimmer, and also smaller, and then suddenly it is the smallest again, and the brightest again, and it gets again bigger. So these are varying in brightness. And Henrietta Leavitt in 1912 discovered that with the length of a period, so by Delta Cepheid 5.37 days, which it takes to go from dim to bright and dim again, is directly linked to the absolute magnitude, so how bright a star actually is. Now, how bright a star actually is can also be seen through what type of a spectrum it is putting out. It is written like that here in the book, so it means probably that what type of radiation, if it is gamma radiation, X-rays, or how exactly, that helps to get the absolute magnitude. But by the Cepheid variable stars, also additionally or only, it's not directly said in this book, what is it now? It can be seen, the star is, the brighter, the longer the period is. And how long the period is can be seen on Earth. So by Delta Cepheid takes 5.37 days, by another star maybe 10 days, 20, 50 days. And the longer the period is, the brighter the star is. And therefore, the absolute magnitude can be seen basically because it can be seen how long it takes to make this changing from dimness to bright to dim, or we are just cycling on, one after the other one. And then comparing this absolute magnitude with the apparent magnitude, so how bright does the star appear on Earth. All the stars in the night at the sky are all pretty bright burning stars, but it is almost dark in the night. And that is because these big burning stars are making almost no light on the Earth because they're so much further away as the sun is from the Earth. The sun is a star and it makes a lot of brightness on the Earth, but these stars are similar bright, but they're making almost no light on Earth. Now that is the apparent magnitude. The stars appear very dim on Earth. And by now comparing the apparent magnitude, so how bright appears it on Earth, and how bright is it actually, because of knowing from what type of radiation is it putting off, or by Cepheid variable stars, how long does it take that period to happen, and the longer the period it takes to happen, the brighter is it. The distance can be calculated, because we know how bright is it, how much light reaches Earth, the distance can be calculated. 600 of these Cepheid variables are known, in this book written in the 1970s, but also Cepheid variables in other galaxies. And these Cepheid variables can be used when the parallax method doesn't work so good. The parallax method, where it is just waited a few months later until the Earth has gone over to the other side of the Sun, and now it can be looked from another position, from another angle onto the star, which is trying to get the distance off. How the background of it have shifted with a shifting of the perspective because the Sun has rotated halfway or whatever around the Earth. It doesn't work by stars which are more than 100 light years or something away. But the Cepheid variable, Cepheid method works also for further distances. And that is according to Reader's Digest Library of Modern Knowledge, Book 1, Part 1, Structure of the Universe, written by Ian Ridpath and Jonas Shakeshift, on several pages, but main article is on the page